Welcome to Math 30-1. We're going to start today with Unit 1, which is called Transformations and Functions. And Chapter 1 is called Function Transformations. And today we're going to do Topic 1.1, which is on horizontal and vertical translations. Now you might remember that earlier from math, translations are slides. A transformation of a function alters the equation and any combination of the location, shape, and orientation of the graph. Points on the original graph correspond to points on the transformed or image graph. The relationship between these sets of points can be called a mapping. Mapping notation can be used to show a relationship between the coordinates of a set of points, x, y, and the coordinates of a corresponding set of points, for instance, x and y plus 3. So that means that x, y would map onto x and y plus 3. One type of a transformation is called a translation. That's what I was saying is the slide. A translation can move the graph of a function up, down, left, or right, and a translation occurs when the location of a graph changes, but not its shape or its orientation. Here we have example 1. We're going to graph translations of the form y minus k is equal to f of x and y is equal to f of x minus h. So we're going to start by graphing the functions y equals x squared, y minus 2 is equal to x squared, and y equals x minus 5 squared on the same set of coordinate axes. Then we're going to be asked how to describe how the graphs of y minus 2 equals x squared and y equals x minus 5 squared are going to compare to our original graph of y equals x squared. So for y equals x squared, we're going to generate some ordered pairs, and then we're going to plot them. We're also going to add 2 to both sides of y minus 2 equals x squared. And that means we're going to graph y equals x squared plus 2, generate some ordered pairs. And thirdly, we're going to generate ordered pairs for y equals x minus 5 squared. Now to put all these three graphs on the same graph, our black graph is going to be our y equals x squared. Our red graph, y equals x squared plus 2, shifts our original graph 2 units up everywhere on the plane. And the graph of y equals x minus 5 squared shifts our entire graph 5 units to the right. B. Y minus 2 equals x squared, or y equals x squared plus 2, shifts our graph 2 units up, and y equals x minus 5 squared shifts our graph 5 units to the right. In our graph, where it says y minus k is equal to f of x minus h, k is equal to 2, and h is equal to 5. On your turn, y plus 1 equals x squared. We'll shift the graph 1 unit down. We can graph to verify. And y equals x plus 3 squared is going to shift the graph 3 units to the left. And again, you can put that into your own graph to verify it. In example 3, determine the equation of a translated function. So we're going to start today with y is equal to x squared. That's the blue graph. Then we're going to figure out how it's transformed to become the red graph. After we've done that, we're supposed to determine the equation of the translated function in the form of y minus k is equal to f of x minus h, f of x being the original function. So if I pick one of the points that's been shifted, the vertex 0, 0 becomes -4, -5. So that would mean that every point xy on my plane, x is going to shift 4 units, and y is going to shift 5 units. 4 units to the left and 5 units down. that means that h is going to have a value of -4 and k is going to have a value of -5. So we're going to say y is equal to x plus 4 squared, so that means a shift to the left, and -5 means 5 units down. The part inside the brackets refers to our horizontal shift, whereas the -5 on the end refers to our vertical shift. Now to write it with the y out front, y plus 5 is simply going to show that the 5 is the shift that goes along with the y, and the 4 is the shift that goes along with the x. That's why it's written in that form. So here we have y plus 5 is f of x plus 4, meaning our original function has now been shifted 4 units to the left and 5 units down. In our second one, instead of writing all the points, just write a sample point. I'm going to use A. A was at -5, +2, and A prime shifted to -1, -7. What happened? Well, x becomes x plus 4. It's going to be shifting 4 units to the right, and y is going to be y minus 9, 9 units down. Now to put that into a function, we're going to say y equals f of x plus 4, meaning that it's going to be 4 units to the right, and -9, meaning 9 units down. And so when you write that in the function notation that they're asking us to, it's going to be y plus 9 is equal to f of x plus 4. Some of you may be confused at the x minus and the y minus, so we're going to just kind of hopefully clear that up right here. Under our key ideas, translations are transformations that shift all points on the graph of a function up, down, left, and right without changing the shape or the orientation of the graph. The table summarizes translations. Y minus k equals f at x, or y equals f at x plus k, is our function. A vertical translation, if k is greater than 0, the translation is up. If k is less than 0, the translation is going to be shifted down. When you write that as a mapping, xy is written as maps onto x and y plus k. Now, if it was negative, it would be shifted down. That's shown in the green graph. If it's positive, it's shifting up. In our second picture, y equals f at x minus h. Horizontal translation, if x is greater than 0, the translation is to the right. And if h is less than 0, the translation is to the left. We write it as xy maps onto x plus h and y, but the equation is written f at x minus h. There's the difference. So when it says x maps onto x plus 4, in the equation, the function is y equals f at x minus 4. A sketch of the graph of y minus k equals f at x minus h, or y equals f at x minus h plus k, can be created by translating key points on the graph of the base function y equals f at x. This is a good time to just take a few minutes, play with some numbers in your calculator, and see how a horizontal and a vertical translation works for different functions. And your assignment then is to do page 12, numbers 1 to 10, and number 17.